Hello geometry students and welcome to another lesson. We are in section 6-3 and we're continuing talking about properties of parallelograms, except now instead of knowing that something is a parallelogram and then applying properties, we're going to see if certain properties are met, and if they are, then the shape is going to be a parallelogram. So what I'd like for you to be able to do by the end of this lesson is to determine whether a quadrilateral is a parallelogram or not. So let's just jump right in. In example 1, it says, show that JKLM is a parallelogram for A equals 3 and B equals 9. State why we can conclude that JKLM is a parallelogram. So this is just going to be a basic concept of substitution. Wherever I see an A, I'm going to put in a 3. And wherever I see a B, whoops, dropped my highlighter. Wherever I see a B, I'm going to substitute in a 9 there. So let's do that. I'm going to have 15 times 3 minus 11. And what I want is to figure out what that value is going to be. So 15 times 3 is 45. 45 minus 11 is equal to 34. So I now know from K to J is 34. So I'll just label that right there. And then let's put 3 in right here. So that is 10 times 3 plus 4. Well, that's equal to 34 as well. So this guy's 34. So now I know that KJ is congruent to LM. So I'm halfway there. Now I need to determine, are these opposite sides congruent? So let's just plug in that 9 where the B is. So that's 5 times 9 plus 6, which is equal to 51. And then I'm going to have 8 times 9 minus 21. So 8 times 9 minus 21, that is also equal to 51. So this guy down here is 51 and this guy up here is 51. Because they are the same value, they are congruent to each other. So I have 2 pairs of opposite sides that are congruent. Because I have that, it is a parallelogram. So it is a parallelogram because both pairs of opposite sides are congruent. And we know they're congruent because when 2 segments have the same length, like for example 34, then that means they're congruent. All right. In the next example, it says, in order for PQRS to be a parallelogram, what must the values of X and Y be? State why we can conclude PQRS is a parallelogram. So in this situation, we want to find the value that Y and X would need to be. Well, if this is a parallelogram, what we would need to happen for it to be a parallelogram, we would need opposite angles to be congruent to each other. And the only way that we can find that value for those angles to be congruent is if we set those values equal to each other. So I'm going to say 6y plus 7 is equal to 8y minus 6. So 6y plus 7 is equal to 8y minus 6. And I'm doing this based off of our properties from the previous lesson that said, in a parallelogram, opposite angles are congruent. I have to have that for something to be a parallelogram, so that's why I'm setting these equal. Now I'm going to start solving for y. So I subtract 6y from both sides, and I get 7 is equal to 2y minus 6. I'm going to add 6 to both sides, and that gets me 13 is equal to 2y. Divide by 2 on either side, and now I have y is equal to 6.5. It's okay that it's a fraction or a decimal. No big deal. So y would need to be 6.5. Another relationship that I need inside of this parallelogram is for consecutive angles to be supplementary. So let me write out both of those properties real fast just so you can see what we're doing. So we need opposite angles congruent and consecutive angles at 180. I'm just going to say it at 180 just to kind of abbreviate supplementary. So now I'm looking at this guy and I'm looking at that guy. These two are supplementary, or consecutive of each other, and they need to be supplementary in order for this to be a parallelogram. So I'm going to figure out what this guy is by plugging in y, and then I'm going to add those up and set them equal to 180. So if I were to plug in 6.5 into it doesn't really matter which one, but we can do this one or this one, into this equation, then it's going to look like this. I'm going to have 8 times 6.5 minus 6. In just a moment, I need to grab my calculator. Okay, so I got my calculator. And that is going to get me, when I take 8 times 6.5, and then I subtract 6 from it, I'm getting 46 degrees. So this guy right here is 46 degrees now. And I should be getting that the same value if I were to plug that in there. So 6 times 6.5 plus 7, 46. Awesome. So now I know 46 degrees plus 15x minus 16, because that's what this angle is, should add up to 180 degrees. So that one was 46. So now let's make our new equations. So I'm going to say 46 plus 15x minus 16 is equal to 180, because this angle plus this angle equals 180 because they're consecutive, and I need them to add up to 180 if it's going to be a parallelogram. So now I have 15x plus 30 is equal to 180. Subtract 30 from both sides. So now I have 15x is equal to 150. If I divide by 15 on both sides, I get x is equal to 10. So why is this a parallelogram? Well, this is a parallelogram because, let me write it in a different color for us. So I'll just write it right here. It is a parallelogram because opposite angles are congruent, and you need both, and consecutive angles are supplementary. All right. Moving on to example 2. It says, determine if each quadrilateral must be a parallelogram. Justify your answer. Okay. I want to remind you that you cannot conclude anything from a photo unless it is specifically marked. So I just want to remind you, photos can be very deceptive. We are not allowed to just assume anything. So we are determining if something must be, meaning there's no other way for it to be anything else. And the way that we can determine if it would or wouldn't be is if we can come up with a counterexample that still meets these requirements. So in example A, I have 63 degrees up here and 117. Well, these do add up to 180. The issue is I don't know what this angle is and I don't know what this angle is. This picture could just be poorly drawn. So another image giving the same exact information could look like this. And I'll do it in pencil because sometimes I don't do so great. So I could still have my 63 degree angle and my 117 degree angle, and you would be correct, those do add up to 180. But what if this line were up and down like that. This picture does not contradict this picture because there is nothing over here in this shape that lets us know that these opposite angles are congruent or that these lines are parallel. If I had symbols on here, then I would have more information, but I'm missing that information, so I am allowed to alter the image without altering the actual data that's in that picture. So this is a counterexample, and we have to say, no, this is not necessarily a parallelogram. In example B, I have one pair of opposite angles that are congruent. The thing is, in a parallelogram, I need both pairs. So I need both pairs of opposite angles to be congruent. The thing is, these do not have to be congruent in order for this image to still work. For example, this could be a kite where it looks like this, where this angle and this angle are still congruent to each other, but clearly this angle and this angle are not congruent to each other. So this one is another no. Now looking over here, I have both diagonals being bisected. That is a property of a parallelogram, and that means that yes, this is a parallelogram. So I'm going to say yes, it has to be a parallelogram because both diagonals are bisected. And then in my final example, I have one pair of opposite angles that are going to be congruent to each other because 107 is congruent to 107. And then I have this 73. Well, 73 and 107, these are consecutive angles, and they do add up to 180 degrees. That then means that this angle also has to equal 73 degrees because I have a limited amount of angle measures that I can have. So if I have two pairs of opposite angles that are congruent and all of my pairs of consecutive angles are supplementary, then yes, this is a parallelogram. So yes, because both pairs of opposite angles are congruent. Cool. So just as a reminder one more time, make sure you do not let a picture mislead you. Pictures are only going to get you so far. You have to make sure that you also have markings and indicators on that image so you know what's going on in it. Okay. Looking at example 3 now. So we have a truck on a lift in this example. So it says a truck sits on a platform of a vehicle lift. Two moving arms raise the platform until a mechanic can fit underneath. Why will the truck always remain parallel to the ground as it is lifted? Explain. Okay. So notice what's going on in this problem. We have a 6-foot bar here and a 6-foot bar here, and as it lifts, it remains 6 foot. So it doesn't matter what orientation the bar is in, it's going to stay that length. So, to begin with, the 6-foot metal bars are going to stay a constant length. They are staying a constant length, which means they are always going to be congruent to each other. So no matter their position, the opposite sides are always congruent. So no matter their position, opposite sides are congruent. The top and bottom bars are also staying the same length no matter what. So the top and bottom bars that are 26 feet are also constant and are always congruent. It's not like this bar is going to be 26 feet in one position and then only be 20 feet in the next. So now I have both pairs of opposite sides are congruent. So both pairs of opposite sides are congruent. Thus, it is a parallelogram. So if it is a parallelogram, why will the truck always remain parallel to the ground? Well, parallelograms have parallel opposite sides. And there we go. So one more time, we knew that opposite sides were going to stay congruent no matter what. 26 is always going to stay congruent to 26, and 6 feet is always going to stay congruent to 6 feet. It doesn't matter if the truck is up in the air or down on the ground. Those stay the same. So because I have two pairs of opposite sides that are congruent, I can say, okay, that's a parallelogram. If it is a parallelogram, then I can apply the definition of a parallelogram, which states that that opposite sides are parallel. So that's why the truck will always be parallel to the ground. Alrighty, we just have one more example. Example 4, it says, can you prove the given quadrilateral is a parallelogram based off of the information? Explain. So given AE is equal to CE, and they're both equal to 14. So right now I know that these guys are congruent to each other, and they're both 14. So I'm just going to label those as 14. And then I know that DB is equal to 2 of EB. So if this guy is equal to 2 EBs, and this is cut into 2 parts, then we would have to then conclude that this guy is congruent to that guy. Because I have both diagonals now being bisected, I would be able to say, yes, this is a parallelogram because both diagonals are bisected. So yes, it is a parallelogram. Parallelogram. Because both diagonals are bisected. Okay, looking at this one, it says the measure of angle Y is 49, so let me put that in there. The measure of angle Z is 131, and the measure of angle X is 131. Okay, first of all, I know 131 and 131, so I have one pair of opposite angles that are congruent to each other. Now, I know that the angles inside a four-sided shape have to add up to 360. So if they add up to 360 and I take one, so let's just say W there. So if I say 131 plus 49 plus 131 plus W equals 360, what am I going to get for that angle W? Okay, so 131 plus 49 plus 131, and then take that away from 360, I get 49 degrees. So W is also 49 degrees. I can then conclude, yes, this is a parallelogram because I have two pairs of opposite angles that are congruent. So yes, It is a parallelogram because both pairs of opposite angles are congruent. And there we have it. I hope you guys have a great night, and if you have questions, be sure to bring them to me tomorrow in class.